Hello, in this video we're going to talk about growing your inner data scientist, tips to success in data science from questions to results. Let's start with who am I? My name is Mina Chetinkaya-Rendell, and I am a professor of the practice in the Department of Statistical Science at Duke University. I'm also a data scientist and an educator at RStudio, and I also write books, so we can call me a book author as well. But I'm also a variety of other things on the web as well. You can find me on Twitter. I write a blog at citizenstatistician.com, and I'm pretty active on GitHub. Most of my projects are there, and you can find me there. And every once in a while, I try to answer questions on Stack Overflow, but frankly, I ask more questions than I answer. But here, those are my other personas on the web as well. And why am I talking about this? Well, before we get into why am I talking about it and how that relates to you, maybe it's worthwhile to take a second to think about, what do I mean by data science? Actually, that's a pretty hard question to answer, I think, mostly because it seems like there is, a lot of ideas about what data science might be. And lots of folks are thinking about this. You can see here like three different representations of people's thoughts of what data science are, and I've included citations for each and every one of them. When we think about it in the context of, how to build a data science curriculum, the things that come about, such as the one in the screenshot from the Berkeley data science curriculum, might feel a little bit different than when you're writing a data science book that's focused on a particular language. So on the top right, you're seeing an excerpt of the data science workflow, or the Krebs cycle in a way, from the R for Data Science book by Hadley Wickham and Garrett Grolemont. And then further down, there's also a bar graph that maybe tells us a little bit about the data scientist profile. Although I've included this as an example of, not something that's super useful, because we don't even know what the y-axis for that graph is. So you may have seen visualizations like this, or Venn diagram visualizations of what data science is. And there are overlaps between the definitions of various definitions of data science, but then there are ways in which they diverge from each other as well. For example, I feel like no one really would go out and say statistics is not a part of data science, but I'm sure that we can find folks who would disagree on how big a part of data science statistics is, and similarly computer science or mathematics or other disciplines as well. Ultimately, data science currently is a bit vague, and it is evolving, but you can still be a data scientist. So in this talk, we're going to talk a little bit about how you can be a data scientist and grow your inner data scientist. And I'm not going to be talking so much about, what courses you should take. So I'm going to be talking more about extracurricular things. So the first thing I'll start with is always be curious. This is probably good advice for being anything that you might want to be, getting better at anything that you might want to get better at, and it applies to data science as well. One way of being curious is keeping yourself informed. This could be via articles you read, like journal articles, books, or blogs. I'll give some examples from blogs, since this might be the sort of thing that doesn't necessarily come up in your curriculum otherwise. There are a few blogs that I like to follow, so I've given examples from that. One of these is a screenshot from the R Weekly newsletter. That's a weekly newsletter that collects data science, particularly focusing on R, though not limited to it necessarily, posts from the community that I find very helpful, because it allows me to kind of just pick and choose the ones that somebody else has already curated. Kieran Haley is a professor at Duke University in sociology who does lots of data visualization work, and I like his writing. Another one of my favorites is Julia Silge, who is a software engineer and data scientist at RStudio, particularly focusing her work on the Tidy Models ecosystem. So if you're interested in more modeling-y blog posts focusing on R, on data science, I would recommend hers. And generally lately, she has been accompanying the blog posts with a video as well. Flowing Data is a blog that's been around forever, I feel like, at least since I was in graduate school, and it is particularly focused on data visualization. The whole Flowing Data ecosystem, there's like a part that where you can learn from Nathaniel, who is the author there. You can take courses from them and whatnot, but there's also these freely available blog posts that I think are nice roundups of data visualization-y things happening on the web. And then finally, on the lower left corner, I have a screenshot from a blog by Lucy D'Agostino McGowan, who is a professor at Wake Forest University, who writes data science-y and R-based things, mostly from a statistician's perspective, which I really, really enjoy as well. So millions and zillions of blogs out there that might be of interest, and I think it's unrealistic to say you're going to read them all. So what you might do is instead find like a curation site like the R Weekly one that I've mentioned, and then have a few favorites that you check in on semi-regularly. I think they're useful ways to keep yourself informed with low effort. Generally, none of these blog posts is going to teach you everything you need to know about a particular subject, but they might be just enough for you to determine whether you want to invest more time in learning about that subject or a tool. Keeping current is equally important. One way I try to keep current is by following folks whose work I engage with on Twitter. Here are a few that I have particularly chosen to include in this presentation because they do both statistics and genomics type of work. You might have your own favorites as well, but the important thing is to find folks who you want to hear from on a regular basis, whether they're talking sometimes about work-related things and sometimes about personal things and sometimes about things that might be in the middle of those two. And if you like their style of writing, if you like the types of projects they're involved with, this might very well be a way to keep current. I would say that in addition to folks whose work overlaps with your area, you might think about following people who tend to retweet things that might be of interest to you. There are lots of folks out there who are good curators of good content on Twitter, and that might be less work for you to just follow one of them and take a look to see what they tend to retweet. And keep engaged. What do I mean by keep engaged? Go to conferences, maybe after COVID, or go to a virtual conference. Go to workshops or give conference talks and give workshops. Go to meetups, join webinars. All of these could conceivably be a full-time job, so you obviously want to be picky with your time, but there are a few resources and organizations you might want to be aware of. For example, the Carpentries organization, along with data carpentry, library carpentry, and software carpentry, which are kind of sub-projects within the Carpentries, do incredible workshops that are data science or programming or software based at a variety of locations around the world. They do virtual workshops as well, but there's probably one in your neck of the woods that if you are wanting to learn about a particular thing, their curriculum is one that would be worth checking, and also to see if you might take one of their workshops and hey, maybe train to be a Carpentries instructor and volunteer your time to work with them as well once you have gained the skills. The webinars are generally a good way to learn, in my opinion, especially if you feel like you can spare an hour to watch through something, either through a live webinar, which might have the benefit of a live Q&A perhaps, or maybe that time isn't good for you. They tend to be recorded and posted on the web. One of the examples I included here is from the RStudio webinars page, but obviously, lots and lots of other resources out there that you might go back and review in your own time. And the nice thing about reviewing in your own time is you might fast forward through bits that make sense to you, or rewind and rewatch bits where you feel like you would like to spend a bit more time. And finally, I mentioned meetups. Probably lots of also meetup groups around you as well. But if you are an R user, which I believe you will at least be partially as part of your curriculum, there is a Galway R users group that you might join and check to see what their meetups look like. Lots of meetups nowadays are happening virtually, but even if so, they're a good opportunity to meet local members of that community and also to keep current with things that are happening around you. Number two is improving your workflow. As important as what you do in terms of data science is how you do it, and how effectively and efficiently you can do it probably contributes to the reproducibility of the things you do, and also just efficiency of your work in general. So investing some time to gain skills for better workflow is crucial. And better workflow is difficult to define because importantly, you want your workflow to match, say, the lab that you're working with, as opposed to inventing your own. Or if you feel like you have a workflow tip that you want to share with the others that you collaborate with or in a lab with, and want to alter their workflow towards something better, you should always feel empowered to recommend that. But in order to be able to do that, you first need to have a well-defined workflow for yourself. One of the best resources that I can recommend in terms of learning about workflow, particularly with in regards to working with R, so computing with R, is this resource called What They Forgot to Teach You About R by Jennifer Bryan and Jim Hester. It has a cute URL as well, rstats.wtf, for what they forgot. And here you will learn a lot about setting up your system properly to be running R, using version control along with R, connecting R with RStudio and with Git and with GitHub. These are the sorts of things that generally in curricula tend to be the bits that we assume students are going to figure out on their own, and many people do. And I am sure each of you are very much capable of figuring out on your own. I think generally when you do figure things out on your own, it might take you a little bit longer than kind of reading through a principled approach. And also you might develop some workflows that may not necessarily be the best workflow out there for accomplishing a particular task, and by the time you figure out that was not the workflow, you may have sunk a lot of hours into debugging something. So I would highly recommend going through this resource. It served as a kind of a web book, and I think it's useful to kind of skim through the chapters to begin with, so you have a sense of what's there, and then dive into the chapters and really step by step follow things where you think you need to kind of learn about that particular aspect of working with R. Other resources that I would recommend are from the R for Data Science book. There are particular chapters here, are just two excerpts from them, but there are a few others in the book that are particularly about workflow. So just either basics of working with R within RStudio, or the notion of an RStudio project and how that can save you a bit of sanity when it comes to working with, organizing your files for a particular project and then working with things like file paths. Number three is share your output. You might, here's an example, here's a kind of a reference to a talk by David Robinson that he gave at RStudio conference in 2019 called The Unreasonable Effectiveness of Public Work. And I think that the timelines or that he developed as part of this talk were very striking to me. So he started by saying, this is how I used to think of my goals. You start with an idea on one end of the timeline that is considered less valuable, and on the other end of the timeline is a published paper, and that's deemed to be more valuable. And in between there, equally spaced, are things like preliminary results, draft manuscript, and completed manuscript. Obviously, we want to have published papers ultimately, but this is not necessarily the only way to think of your goals. And I think you should broaden your sense of what is considered valuable. Papers are one thing that is valuable, but it's not the end-all be-all. And really, this timeline can be considered more like anything that's still just on your computer: data, code, results, draft, finish paper is less valuable, versus anything out in the world that's paper, preprint, product, blog post, open source, tweet, what have you, is more valuable. And out in the world doesn't always have to mean in the public eye for millions of people to see. First of all, millions of people are, let's be honest, probably aren't looking at your work. If they were, you would be quite happy about that. So I think that we want to break that barrier of thinking about, am I ready to share this with the world, with millions of people? And chances are you're actually sharing it with a much smaller number of people who could actually benefit from it, even if your work is more of a work in progress than a polished published paper. Anything out in the world might also just be something that's just not on your computer alone, but one that's been shared with collaborators as well. And generally, when we start working on projects, we think about, okay, who am I ready to share this with? Who are my collaborators? Let's keep things private to them. And every once in a while, there may be a good reason to do this, in terms of, some of us have worries about our papers being scooped and whatnot. So if that's kind of your, if that is a common problem in your area, that might be something you want to be careful about. But generally, just being able to have your code and your analysis publicly shared with the world will prompt you, I think, to do more high quality work to begin with, at a minimum more reproducible work, and will also prompt you to be more organized about your work. And your collaborators will, likely be the few people who are seeing it anyway. But when you finally do have something like a paper published, it's quite difficult to go back and try to, open source everything after a paper is published. Generally, that's when you want to move on to a project. So if you actually include that into your workflow to be out in the world to begin with, you can still get to that published paper that will add some value to your academic career, but you'll have the artifacts that are already publicly shared with the rest of the world as well, and it won't feel like an extra burden at the time. But as I said, the papers are only one part of the story. Think about all the other things that you could be publishing with the world that will make you a better data scientist just by the virtue of going through the process of publishing them, and also make that information available for others to consume and learn from as well. So share the things you create. These could be big things that you create. Here's an example of a project that I've been maintaining for a number of years now called Data Science in a Box. And basically the way this started is that I still am teaching an introductory data science course. I tend to whenever I teach a course, open source the materials for that course and share it with the rest of the world. So I thought, well, we do tend to share these with the rest of the world, but they're generally in the context of a single course. What if I actually shared it with the rest of the world with the deliberate purpose of other educators to be able to borrow from, learn from, but also teach out of as well. So basically open sourcing the entire curriculum and serving it to the community with a little bit of additional work, with some narrative around how you could actually teach with this. If you are going to share something like this, it's important to think about licensing as well. Generally, a Creative Commons license is commonly used for open source work. Open source software and open source other resources tend to get slightly different licenses. So something like an attribution share alike is a common way of sharing, for example, educational resources. You might choose to share them in a way where they're restricted to non-commercial use. For this one, I did not make that restriction, but importantly, pick a license. Probably, if you're new to picking licenses, think about picking a Creative Commons license. Look at what others in your discipline and community, how they are sharing their open source work, but put that there. That way, you get to define the terms of use for the resources that you share with the rest of the world. And you get, if you like, acknowledgement, if you put the attribution there, acknowledgement when others use your work as well. You can also share the little things you create. So here is a random thing that I stumbled upon recently. I make my slides generally with an R package called ShareEngine, which is an R Markdown based slide generator where the result is an HTML document ultimately. And I realized that I can actually embed kind of screens from this app called Slido, which is used for kind of audience participation into my slides simply by using an iframe. So I was basically able to build into my slides something like a clicker where people would, students can vote on questions, their answers, or they can write up some discussion notes with their teams and submit them as they are viewing the slides on their computer without the need to download a separate app or go to a separate web page. So I shared this, and generally whenever I have something little to share like this, I try to do that in a tweet. Seems even less work than writing a blog post. I try to do that with screenshots to help folks, and whenever I include screenshots, I try to include some alt text as well, both for folks who are visually impaired and who may not be able to see the screenshots you're sharing, but even if not, for anybody who is viewing this, so that they can get a better sense of why you're including that screenshot in the first place. And so you can see that alternative text at the bottom of this tweet as well. You know, it got some engagement, you can see at the bottom, but importantly, I have heard from some educators that they started using the same trick the next day as well. It's a free thing I stumbled upon, and I figured, why not share with the rest of the world? And as you share things like this, you get more comfortable sharing, you get a sense of what others are, in your community are interested in hearing from you. This is the sort of stuff that, you might just turn around and talk to your office mate about, and that's great, and you should continue to keep that, but it's also nice to share them with the rest of the world as well. And also share the things you learn. This is a quote from Mara Averick, who is a developer advocate with the Tidyverse team at our studio. She is very well known for her Twitter feed that tends to be highly informative, because a lot of what she does is what she calls learn out loud. That is, if she stumbles upon a good blog post, that she has learned from, she makes sure to retweet that, oftentimes with a brief summary of her own. So not only do you end up getting by following her, learning about new things, or whether that's a new tool, a new package, or just a new tutorial to learn something better, but you also get to kind of hear her take and her summary of it as well. So one of the things that I had shared at some point while I was the curator for the We Are Our Ladies account was this way for doing column selection in the RStudio editor. This is actually probably something you can do in any plain text editor, but what you need to do is to click on Alt and click at the same time, and you can basically write on many lines simultaneously. It's also great for commenting out many lines at once. This is probably one of those tweets where every once in a while I'll see gets more likes, because people really enjoy seeing things like this. It's quite easy to learn something like this from a tweet, and if you have the privilege of seeing others code, which as part of being in an educational program you probably will, which is great, but a lot of people tend to learn to code on their own, reading static things like books and blog posts and stuff like that. And oftentimes a lot of the videos you stumble upon tend to be kind of slideshows like the one you're watching right now, as opposed to a live coding session. So you don't get to pick up these kind of workflow tips along the way. So if you stumble upon, again, things like this that you think are like, hey, this is cool, I really like it, share it with the rest of the world, because chances are somebody else will like it as well. And importantly, they will remember you. And it's useful to kind of, continue to get your name out there, both with the big things you work on, but also with the small things you stumble upon. Here's another example of that, something that I stumbled upon very recently. I have been using ggplot2 probably since it's been around, and definitely very religiously over the last 5 or 6 years or so. And I teach ggplot2 every single day as well, but it turns out there's an argument in one of the functions that allows you to visually debug where text is placed on your plot. And if you've ever tried to use ggplot2 to annotate a plot, my guess is you may have been frustrated by not knowing what parameters to set for kind of arguments of functions that can be used for annotation, like text annotation. And so this allows you to set debug equals true, and we'll draw these kind of boxes around where the area where the text is going to be plotted is, so you can actually see visually how changing the parameters actually get reflected in kind of your plotting window. Again, something that ended up getting lots of interaction on Twitter because people didn't know about it, because it is something that's buried in the docs, or folks who did know about it said, yes, of course, this is something I use all the time. So if you just stumble upon something that you learned that you think is cool, that's another thing to share as well. Don't think about things that you want to share as things that you have created only, but also as things that you have learned as well. Here's another example of from back in the day when I realized, what happens if you mix up, for example, the two operators. One is the pipe operator that you would use with a dplyr package, and the other is the plus operator that you would use with a ggplot2 package. And what if you use one instead of the other? It actually gave you back then a pretty bizarre error. That, by reading that error, that's at the bottom of the screen, that it says mapping should be a list of unevaluated mappings, yada, 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 it would be really difficult to figure out that that's what's going on. But here's an example of something that I was like, you know what, I'm going to blog about this, because next time I Google this error, I want to stumble upon this blog post so that I know the error that I made, and I would like for it to be helpful to others as well. And actually now, since March 2019, it actually, the Tidyverse has adopted a better error based on, I think, I wouldn't say necessarily based on this blog post per se, but based on comments like this that came about saying, wouldn't it be nice if the error just told us what was going on instead of this bizarre kind of string of letters that we need to parse through and remember, this thing I'm reading actually means this error. So now if you actually mix up your operators, you get a pretty nice error. So sometimes sharing things like this can actually result in changes to the tooling that you're using in a better way, such that you end up being part of kind of a good change along the way. And also share your questions. Here is a quote from The Art of Problem Solving by Tiago Macieira, which says, the most useless problem statement that one can face is, it doesn't work. Yet we seem to get it far too often. So when you are asking a question, it doesn't work, is not very helpful. You want to be thinking about, how can I ask this question so that somebody else will actually not only just want to answer, but will be able to answer. So there is a really nice paper that I would recommend reading called The 10 Simple Rules for Getting Help from Online Scientific Communities. It is quite short to read, kind of in fact written as almost like 10 expanded bullet points. And I think that it's a really helpful way to kind of for you, a really nice write-up of what you should have in the back of your mind when you're gearing up to ask a question on an online scientific community. The first is, don't be afraid to ask a question. Second, state the question clearly. Third, learn established customs before posting. Fourth, don't ask what has already been answered, which I will say with a caveat, this is true, which means you should do your diligence before asking a question. But sometimes if you are, immensely puzzled by a problem, it may not be clear to you that a question that has already been answered is the same as your own. So I think that this step 4, while quite important, can sometimes be in a way paralyzing. And I would encourage you to do your diligence, but then also remember about step 1, don't be afraid to ask a question. Always use a good title. Do your homework before posting, do a little bit of researching, proofread your post, be courteous to other forum members. Remember that the archive of your question can be helpful to others as well. So don't make it so personal in a way such that it won't be helpful to somebody else. Use, for example, an example that others will be able to easily generate and reproduce as well. And finally, give back to the community. Once you are getting your questions answered, remember that it was some volunteer who, took the time out of their day to answer those questions. And once you feel comfortable, once you get to a place where you feel comfortable doing so, you may start doing that as well yourself. So suppose that your goal is to create this character string. So we have numbers and we have letters attached to them. So here's one way to ask a question. I'm trying to create the following vector in R. It has 5 elements. The first element is 1a, second one is 2b, third one is 3c, fourth one is 4d, fifth one is 5e. So I define x to be 1 through 5 and y to be the first 5 letters of the alphabet. But when I add them, I get the following error. And the error says error in x plus y, non-numeric argument to binary operator. Okay, maybe some of you are actually able to conceptualize in your mind what this question asker has actually done, but I'm guessing some of you don't exactly know what they have actually done. And even those of you who have been able to figure out what they have done to get this error are probably squinting your eyes and thinking, I just wish they kind of put down in their question exactly the code they wrote. So that's really what you want to be doing. Here is one way of doing this. You might say, ask the same question. I'm trying to create the following vector in R. Below is a screenshot of what I tried. Why is it not working? This is a better question because at least we can see the code that they ran. But what is the problem with a screenshot? That's now an image. How am I supposed to grab their code and reproduce what they did as a starting point for trying to help them? Sometimes maybe the answer is so clear to the person who might be answering the question that a screenshot could work, but more often than not, they're going to want to run your code first. And nobody wants to type out code that they're seeing in a screenshot to begin with, however short that might be. So while this is an improvement, then the previous question that read more like, guess what I did, this is still not quite there either. So writing good questions is important, and particularly if you're writing questions about R, I would very much encourage you to use the Reprex package for doing that. So Reprex is useful for preparing reproducible examples for posting to places like GitHub, Stack Overflow, or even Slack snippets. So here is what you might do. The question is saying, I'm trying to create the following vector in R. Below is what I tried. What does this error mean and how can I fix it? So what we have done here is we've written the code. So that's the first 3 lines here you're seeing on your screen, assigning the numbers 1 through 5 to X and the letters 1 through 5 to Y, and then adding the 2 of them up with the addition operator. And then highlighted that code and reprexed it. That means that while that's in our, so copied that code, and while that's in our clipboard, ran the command reprex, which will then create this snippet that you're seeing where the R code does not have those carriage returns at the beginning. So somebody can actually copy this and paste it into their R session and run the code. And then the result is commented out. So even if they copy the result as well and pasted that into their R session and try to run the code, since that is commented out, that's not going to get in the way. So this is really a lot more helpful to somebody who might want to help you because you have given them a way of quickly reproducing the error so that they can help you with things. Number 4 is contribute to community. So how can you contribute to community? I encourage you all to find open source projects that you enjoy and start contributing to them. This might seem overwhelming at first, but I think there are a few tips that you can keep in mind. First of all, you can do something like contributing to books. The R for Data Science book is one I've contributed to in the past, and here's how I've contributed to it. Mostly text typos, that's basically what I had the first time I contributed to it. What kind of text typos are we talking about? Really just making a few wording suggestions and, fixing a few typos. Is this really, valuable work in what one might consider as original writing? Not necessarily, but it was a way of starting to get some practice with contributing to open source projects. So don't hesitate to start small. Even a comma here, typo fix there, or maybe providing a translation somewhere if you speak a language that's different than the original language that, say, a documentation was prepared in or something, might be immensely useful. You might also contribute to things like packages. Here's an example of, I'll give again a small example where I have, contributed to a package. This was to the glue package, which is used for creating text strings. Kind of similar functionality to the paste function, except doing so in a way where you're using the curly braces to denote variables that are going to be kind of pasted into your text string, or in other words, glued into your text string. And the particular function that I thought was very useful to use along with mutate did not have an example in the function kind of definition that used this mutate. So I figured, let's try contributing an example to it. So what are some things to keep in mind before you contribute to an open source software? First of all, you want to get the pulse of a project. Is this one where lots of members are contributing to, or is it one that's only maintained and code is written by a select few people? Another thing you might want to do is watch the repository where the project is being developed. So if the project is on GitHub, for example, there's a little watch icon. So you might start watching it for repositories that are very popular that might potentially generate a lot of emails to you. So do it at your kind of own risk, but it is another good way of getting the pulse of a project. And read the code. This is incredibly important, that before you contribute to the code, you need to read the code to, one, make sure you understand how the code is written in the first place, but also to get a sense of the style of the code in this project. Review the code of conduct and the contributing guide. A lot of projects on GitHub have these, or a lot of open source projects, whether on GitHub or elsewhere, have such documentation that's really important to read through before you start contributing. And discuss your ideas. Open an issue saying, I think X would be a valuable addition to this package. And see how much traction that gets, maybe how much the maintainer of that project thinks that's a good idea as well. And finally, if once you discuss your ideas, they sound like a good idea and they've, in a way been discussed and others said, yeah, why don't you go ahead and implement it, that's the time to make a pull request. If you're just fixing typos, you probably can skip the discuss your ideas step, right, and make a pull request. That's after you get the pulse of the project to see if this is a common sort of thing that's done, but that is generally the case with most open source software. Number 5, collaborate with others. You might collaborate on something like process. So pair programming is a really useful technique for kind of learning from each other by coding at the same time with another collaborator. This could be something you do in person, or it could be something you do kind of virtually as well, where one of the people in the pair is called the driver and the other one is called the navigator, or in a way the backseat driver maybe. So one of them, has their fingers on the keyboard and actually typing code, and the other one is walking them through it. And the idea is that if you're pair programming with somebody at the same level as you, you constantly switch, right? Every 5 minutes or 10 minutes, you switch roles so that each person, gets to do each of the roles, but you're basically concentrated on the same thing. Alternatively, if you're learning from somebody, it might help that the person who's a bit more experienced is the navigator, and you are the person who is doing the driving, in other words, the coding. You might also collaborate in your classes. Say you have a class project, you might turn that into a blog post with your team that you've created the project with, or a portfolio entry, or maybe a competition submission. There are lots and lots of data science competitions out there. You might collaborate outside of class by entering in something like the Kaggle prediction competition. There is a computing award from the American Statistical Association, ASA, from the statistical computing section, and this might be, if you have built some software, statistical software, this might be a good venue to submit it to. There's also the statistical computing section also has a student paper competition each year as well that you might submit a computing related paper to, which lots of data science stuff tends to go in that area. And broadcast your work. Maybe that's just making some data visualizations. The Tidy Tuesday project is a great venue for this. Every Monday, there's a new data set release, and every Tuesday, people share the visualizations they have made or the tables they've made based on this new data set on Twitter with the Tidy Tuesday hashtag. Whether that week you actually participate by doing and creating a visualization or just perusing and learning from others who have done so, I think it's a great kind of community to get involved with and, get to learn new tricks every week. Also speak at events. Join the R Users group and speak there. Join your local R Ladies group and speak there, whether that's giving a workshop or a full-length talk or a 5-minute lightning talk. If there isn't such an option, the venue that you'd like to speak at, and particularly if that's a friendly meetup, suggest it as an option. Generally, that's a great way to give your first talk. Write blog posts. If you are going to be writing blog posts that have some R component to it, I recommend the Blogdown package for doing that, because it allows you to write posts using kind of R Markdown structures. There's a Blogdown book that's pretty helpful for learning about how to get started with that. Allison Hill, who works on the R Markdown team, also has this blog post, actually a pretty recent one from this year, that walks you through the steps of up and running with Blogdown if you're interested in doing so. Keeping a blog alive is harder than getting started with a blog, because getting started with a blog nowadays just means, write a bit of code and deploy it online somewhere, which you could do in an afternoon. Keeping a blog alive is like keeping a plant alive. It requires dedication. I would recommend finding co-authors. It's hard to, generate always by yourself, but if you have one or two friends that you might co-author a blog with, it might make it easier to keep a cadence. Keeping it regular is helpful. If every week seems impossible, make it every other week. If that seems impossible, make it every month. But if you are writing a blog for more than just notes to yourself, that you are actually trying to grow an audience who's interested in your blog, you're going to want to keep it regular. If it's meant to be just, whenever I have thoughts, I'll jot them down, then obviously you don't need to do that. Writing themed posts can help. So think about a theme, and then, write, maybe every other post is going to be about this theme, or for the next X months, I'm going to be writing about this particular theme. That might help you get inspired. If you join events, you might review them, and that might be an easy blog post to kind of write that might help you keep a cadence, but also keep you writing. The more you write, the easier it gets to write the next one. So here are the 6 tips that I mentioned throughout this talk for growing your inner data scientist. Always be curious, improve your workflow, share your output, contribute to community, collaborate with others, and broadcast your work. And here's the last one. You know, you're all PhD students, and extracurricular projects that are in no way connected to your dissertation can be pretty attractive at times, and probably your dissertation is going to be staring at you thinking, what are you doing? Get back here. So obviously none of this is meant to distract you from your main line of work, but I think they are ways that can actually make you a stronger data scientist, a stronger statistician, a stronger, whatever you want to be, because they will keep your skills growing and current and keep you writing and sharing with the rest of the world. Thank you very much for listening, and if you'd like to review the slides, particularly for the links that I mentioned throughout, you can find them at bit.ly/grow-ds-21. And if you'd like to hear more from me, you can find me on Twitter at my handle there, Mina Bajek, or if you want to find out about my projects, I'm on GitHub at Mina Chetinkaya Rundell.